Hello, welcome to workshop 3. In this workshop, what we're going to do is we're going to create a headless server, or we can use one that we've already created. When I do these exercises, I'm just going to slide in ones I've got all pre-created, just to make things go a bit quicker, but you will need to create your own. I'm then going to install Bind9 and the utilities, and then I'm going to configure Bind9 as a caching server using forwarders. And then what we're going to do is try and run some queries and run Wireshark in a couple of different ways to try and capture the traffic so we can identify where things are coming from and where they're going to. So what do we need to do first of all? Well, first of all, we need to create a new machine. We then carry out a full installation. We can do that if we like. Or we can copy a machine from the NAS drive if we have access to it, or we can use our backup machine which we created in the last workshop. In my case, what I'm going to be doing is I am going to be using this machine here which I created, and if you remember, I created a machine and called it CGNE1. So if I clear the screen on here, that's the machine I actually had. So that's what I'm going to use for that. The other thing is I'm going to, when I built that machine, put the utilities on it. I'm then going to run some queries, and I use the virtualized desktop. Again, I'll use the one that I created before, which is here. So let's see what we need to do first of all. We need to install Bind9 and the utilities and configure the forwarders. Now, is there any little prerequisites? Okay, we'll do it from our client machine because we created it and I've got a fixed address on mine. So what I'll do is I will open up a console. I'll just expand that, and if I go SSH student at 192.168.100.150. Now I'm aware that I've got that address wrong at the beginning, so I'll fix that. And that is at 10. Okay, so we're ready to get connected now. I've already connected that machine before, so it asks me for a password. I put my password in and I'm connected. If I do an IPA, I can see that the machine that console is on is 150, so I'm on the machine. So we can clear the screen. Okay, so what do I need to do? I need to install Bind and the DNS utilities. So install sudo apt install Bind9 and DNS utils. Put in the password and we should get a nice installation. Yes, install those. Okay, that's finished. So if I now do ps-ef grep, we'll do a named this time. Oops, I need a pipe, sorry. And there we can see it's running, so quite happy with that. So what's the next thing I need to do? Let's move that out of the way for a second. That's installed. Configure the machine to use forwarders. Okay, so first thing we need to do then is we need to go sudo nano /etc/bind/n. If I press the tab key, named.conf, put in the O, tab key again, and there we have it. Now if I come down, there's my cert, I've already checked it, and here's my forwarders. So now I need to add them in. To do that, take the comments out. That red line there is very simple, it's just there's a tab there which I don't need, so I've deleted it. Now I'm not connected to the laboratory network, so I need to go to 8.8.8.8, and I'm also going to use the other Google server 8.8.4.4. Save those files, exit out, and now I must restart Bind to reload those settings. So sudo systemctl restart Bind9. Comes back and it's now loaded them. Okay, let's see what we need to do next. So that's the first part done. in Wireshark and expand. Test some queries against your DNS server. Okay, let's bring the client back in and let's do some of that testing. Okay, so we're going to use some Wireshark, so we'll run that in here. So let's get that running first of all. So oh, no. We don't run Wireshark first. What we need to do is we need to start running the queries. Now, there's a couple of ways we can do this. One is we can use NSLOOKUP, and given it a URL, we can actually specify the IP address of the server we want to run it off. The other thing we can do, using the -type equals A option, we can force it to pull back specifically A records, which are IP4. So that's one way to do it. So let's say I wanted to pull back the IP address for google.com, and I wanted to specifically pull that back from the Google servers. I can do that and I get my IP4 address, which is fine. But what I want to be able to do, because if we look back at this, it says capture the traffic effectively, and down here set the virtual to use your name server. Okay, so how are we going to do that? Well, to set it to our name server, we're going to have to go into our wired settings. And in here, what we have is our IP4 settings. And we need to say, don't be automatic, because it's picking that from the DHCP server, which is not the correct one for us. So we set it to our IP. Oh, sorry, put the wrong address in there. So my machine, my DNS server that I've set up is that one. So I'll apply that. Now the other thing is, I need to restart the network card to reload those settings. So that's that done. It's reconnect the network, it's automatically found a printer, but that's by the by. The next thing we need to do though is we need to actually make sure every time we run queries we do not pull results back from our local cache. Now I said DNS servers can run as caching servers, but local machines also have what we call a resolver cache. So to be sure I'm getting the right results, if ever I do a query, what I should really do is also flush the resolver. So sudo systemd resolve -- flush cache. Running that clears the local cache. So when I run any queries, they will definitely go to the server. So if I run that query, it will use that server, but it will also cache the result locally. So I need to clear that to be sure everything is going to come through and I'm testing the servers correctly. So flushing the cache allows me to do that. Okay, I've saved my server. I've given it the new IP address. Let's move this out of the way a second. Right, let's have a look at number 4 now. So we're going to test some queries. So to do that, I'm going to bring in my client machine so we can actually run some tests. So let's have a look at what we can do. First of all, what we'll need to do is, what does it say here? Set the virtual client to use the name server. Okay, so we'll do that. What else do we need to do? We also need to do some effective capturing. So I'll use a couple of little filters to do that. And then we'll identify, as it says here, we'll identify the server's communications. So we'll do that all in here. So let's get started. First things first, go to the wired settings. And let's have a look at our server settings. It's currently using the right server. Okay, so automatic is switched off. I'm using the right server. So what do I want to do now then? Okay, well now I'm using the correct server. What I want to do is I now want to start running a query. So if I do an NSLOOKUP on www.google.com, that will actually go against the correct server. So what I want to do is I want to have Wireshark running and capturing traffic for me while I do the query. Okay, so there it is, and I'm going to capture DNS traffic, and to make my life a little bit easier, I'm going to say that it must contain the text. DNS contains, and it needs to contain Google. Okay, so that's my filter, which I will apply. So that is a display filter, not a capture filter. So I'll run Wireshark, and I'm now capturing the DNS traffic. So if I now go back to my command prompt, if I run that query, I get an answer back. In that case, I've got an IP4 and an IP6. That's not really what I wanted to do. What I wanted to do there was just capture the IP4. So what I'm going to do is add in -type equals A for A records and run it again. But before I do that, I'll restart Wireshark because I've ended up with quite a few things in here that I didn't want. So what we'll do is we'll stop that and we'll restart the capture. What I'm also going to do, which is something that's worth bearing in mind, is that whenever you actually use the server, things will be cached on the server and, as I said, on the resolver. So we've been clearing it. So there's a couple of things I need to do. What I'm going to do is bring my server back in because I want this to be a clean server. So what I will do is I will restart bind9. That will clear all the cache, etc. in there from my caching server. So I've got a clean server running. And I've also got my client running. So what I'm going to do is I'm now going to start the connection, start the capture, go back to my prompt, and I'll run it and just do a type equals A. There we go. And I've just got the one answer back because I only asked for the one. So let's go back to Wireshark. And we'll stop the capture. Why have I got no capture? Quit without saving. Maybe that was on the wrong port. Let's try it again. Oops, let's try again. So do Wireshark, get that running. Display filter, DNS contains Google. Apply that. So I'm capturing. Let's go back to here. Oops, wrong one. Let's go back to here. Again, let's make sure our server is absolutely bare bones. We don't want to have any problems. That server restarted, and now what we will do is we will execute that query again. Okay, let's go back to Wireshark now. And I'm now not getting it still. Okay, let's take the filter off and see what's happening. Ah, of course. What did I do? I didn't clear my local cache. Stop the capture. DNS contains Google. What I will do is I will clear my resolver cache. There we go. Sometimes DNS, with the way it optimizes things, when you're trying to build it and look at it, can actually get in the way. So you've got to be very careful when you're running these kinds of tests. So, okay. Let's go back to Wireshark again. What do we get? Well, we've got a load there. Let's do the filter. Google. Okay. Filtering for Google. We now come along. We've filtered the cache. We now run the query. We've got our answer. Now, where did that query go? Filters on again. Let's have a look. Is there any DNS traffic at all there? Yes, there is. Quite a lot, actually, but nothing of what I wanted. So there we go. Doesn't always work. Let's start again. DNS contains Google. Flush my resolver. Restart my bind server. Hold on a moment. Am I on the right DNS? (10.150). Yes, I am. Okay, let's just make sure that is correct and restart that. That might have caused some problems in Google, but in here, but here's hoping. Okay. Start capturing packets. And now we'll run that query again. There we go. Okay, now let's go back to Google. There we go. Right, that took a little bit of work, but there we go. These are the kinds of problems we have. Okay, here is the query I did for Google. And as you can see, my machine queried 100.150. And if we go into the top of this, we can have a look, and we can see there's the query, and my response is in packet 66. Let's just quickly open that up and look at the query. The query was for Google, a record. So if we go to here, we can see we queried looking for an A record, google.com, and we got the answer, 216.58.204.36. So let's go back, and we go back to the packet where we got the response. If we open that up, there's the query, and the answer is 216.58.204.36. So there we go. Request was in 61, and the answer is in packet 66. So what are the packets in between? Well, my machine spoke to my DNS server as it should. But notice the server then spoke to 8.8.4.4. 8.8.4.4 then came back with a response. At that point, we jump to here, and the server then supplied me with the result. So the caching server has sat in the middle and done the work for me. Now, let's run that query again and see what happens. So I'll stop that query. I won't restart the server. We'll leave the server where it is. But we're going to restart that capture. We've got the filter applied. And now what I'll do is I will clear my local resolver, and I'll run that query again. And let's see where the result comes from. I flush the cache. I run the query, and I get the same answer. Now, we didn't notice any speed difference there, but there will have been. Because now look what happens to the query. The query has gone to the server. The server has responded immediately with the answer. And that's because that record is now cached. Okay, so that's the Google. Exactly the same thing will happen with northumbria.ac.uk. So I want to jump forward to the next query, which is offcampusnetwork.co.uk. And what we're going to do is have a look to see how things work differently. To make life a bit easier, we're going to set up another display filter, and this one we'll put the display filter in of campus, and we'll apply that. So there's no queries there at the moment. If we go into here, I will now run the query to look for offcampusnetwork.co.uk. Now where's the answer for that going to come from? Well, it says it can't find an answer. So how did that happen? Okay, let's have a look at Wireshark. Well, it's very similar, because here's my query. And we see the query was for offcampusnetwork.co.uk, and my response is in 470. So let's have a look at 470. Here we go. There's my response. And the response we got was from the server back to myself. But what happened in between there? Well, basically what happened was the server didn't have the answer, so it went to the internet, to 8.8.4.4. And that responded with no such name. That answer was then forwarded to the client from the server. So what happens if I run that query again? Well, we'll stop that and we'll run it. So this is a query where there is no answer. So we run the query again, and let's see what we get this time. Oh, sorry. I will flush first from my resolver. Let's have a look. It did do the query, but I'm going to clear that. We'll stop that and start it again. Okay, I cleared my local resolver, and now I'll run the query again. Now let's have a look in Wireshark. Well, this time the query's gone just to the machine and back again. So here it is. So there we go. There's the query. And the query was for offcampusnetwork.co.uk. Answer is in 57. And in 57, we actually get the response that there is nothing. No answer. So, in effect, it's now caching to say that doesn't exist, but it didn't go to the internet to do it this time. So that's optimizing how we use the DNS service. So what do we need to do next? Okay, now let's set the virtual client to use 8.8.8. So I'm going to bypass my server. and let's see what happens. So I go to the wired connection, I change my network settings, change my IP, and change it to use 8.8.8.8 and apply that. Restart the network card, go back to Wireshark and restart my capture. This time I need to go to Google. Okay, filtering Google traffic. Just to be sure everything's clear on my machine, I'll flush the cache. And now what I'm going to do is I'm going to rerun that query for google.com. And let's see where the query goes now. Got an answer just the same. It's gone to my local machine, so it's using my local resolver. So let's have a look at Wireshark. And all Wireshark shows me is one query. 10.168.113, it's gone to 888. So I haven't even used the server I've built, and I got an answer from that machine. Was that cached on that server? I don't know. All of that back-end traffic I have no control over, but I've used that machine directly. I can do the same again if we have a look at the next query for northumbria.ac.uk. So we can go here and we'll do Northumbria. I'm now filtering for that. If I go along now and run another query, and the query I do now is for northumbria.ac.uk. I get an answer, I go and have a look, and again, there's just two queries. There's just the query and the answer, nothing else. I've got no idea what that's doing. And finally, what we'll do is we'll use NS lookup and we'll bypass that, where I've got this passed, to an even different server. I'm going to go back to 8844. So let's have a look at that. So in here, just to be sure everything's clean, flush the cache, my local cache. And now what we're going to do is we're going to do a look for, let's just go up and find it, off-campus network. Oops, wrong one. Flush the cache. Let's force it from 8.8.4.4. Let's go to Wireshark. Start capturing packets. We want DNS. Contains. And what does it have to contain? It has to contain campus. Okay, there we go. I'm capturing campus now. We go back to my client machine. Let's clear the cache. Let's get rid of it. And now I'll run that against 8.8.4.4. Okay, it comes straight back and says no answer. We have a look at the trail now in Wireshark and the machine. There we go. It's queried 8.8.4.4 directly, and then 8.8.4.4 has come back with the answer. So I completely moved away just by using the NS lookup command. Now, where did those redirections go with the first lot of queries? When we did these queries up here and we used the virtual client on our name server, we ended up getting these relayed queries, or seeing where the query was forwarded on. And the reason for that is because of what we have in our actual server. So if we bring the server back in and have a look, when we ran those queries, the first batch of queries, what we were actually doing was we were actually being forwarded by these forwarders here. So we've got a list of forwarders. It randomly chooses those. So in this case, ours decided to use, those first set of queries decided to use 8.8.4.4. So that's how the queries end up where they are. So we can now close down Wireshark, move this out of the way. And let's do a quick run through, because that's the end. Let's do a quick run through of what we've done. Okay, we've built our server machine. We've added in bind and the utilities so we can actually look at things. We've configured the forwarders to use two possible forwarders, 8.8.8.8 and 8.8.4.4. We've then used Wireshark inside the virtual machine, and we've tracked the transactions across from the client to our DNS server. The DNS server that we created then doing queries out over to the Google servers. And then what we've done is we've changed, so we've used a completely different server outside of our network, and anything that happens in the back we couldn't see. But what we could do was still get the answers. Then what we did, using the NS lookup, we directed our query to a specific machine away from ours. So that's how it all works, basically. That's how a caching server works. So that's the end of workshop 3.